Hey, how's it going, man? Yes, we can hear
Yep. All right. There we go. All right. I got it.
you.
So
How's it going, man?
it's going fine. So
That's good.
I got I got a chance to hear you talk about what you think about gravity,
Hey, yeah,
and I don't agree with your take on gravity, but I watched your, I guess, short, uh, and you seem to indicate that you think it's density and buoyancy, which I've heard before, but I don't know if I got that right.
no, no. It's relative density disequilibrium. Density and buoyancy is based on specific gravity, and yeah, that's why I don't like the word density and buoyancy, though.
Okay.
But do you understand what relative density disequilibrium is?
Well, I understand. I think I understand what you think it is, and I understand, what I think it is. So, we should separate those two different things, right?
I agree.
Okay,
No, I
let's
agree
see.
because I see a lot of the time people want to rope relative density disequilibrium in with specific gravity and say, you see, but you require gravity for this, and we say, no, but it's two different things. We
Okay,
yeah,
so why do you think buoyancy happens? Why does the helium balloon get pushed up?
it's
Or
just Archimedes principles based on displacement.
right?
We
So
don't, and we,
everything is moving. Everything has a downward bias, right?
no,
The air does, and the helium does.
no,
Oh, okay.
not everything has a downward bias.
No, some things go up.
Well,
Air moves in all directions, not down.
so okay. So let's like, examine that. This is what I think is happening. Everything has a downward bias that may not overcome buoyancy, but it contributes to buoyancy when the denser uh, of the medium is being pulled down and gathers underneath the lighter, uh, material, the less dense material, which has the effect of lifting it up. So, for example, if you put the beach ball into water, the beach ball has a downward bias. If you let it go in the air, it'll fall to the ground. If you let it go in a vacuum, it will fall to the ground. However, the water also has a downward bias. If you let it go in the air, it will fall to the ground. And the water is denser than the mostly air-filled beach ball, right?
Mm-hmm.
So buoyancy happens because that downward bias is causing the water to stay, to have a greater force holding it under the beach ball, which is why if you submerge the beach ball, pulling it down and let it go, the water will crowd under it and push to the surface. That's how
Okay.
I think buoyancy works.
But
Yeah, but did you see? That's the thing. You're assuming it's being pulled to the ground, downward bias. Like I said, there is no downward bias. It's just simply an equilibrium state. So
So you don't think things would fall down?
no, things go down based on their displacement ratios.
Well,
The
yeah.
object
Why not
between the
sideways?
medium.
Why not some other direction? That's why I'm calling it a downward
Because
bias. I would think you
yeah,
would
but there
agree with
there
that.
is no such thing as a downward bias because things go up. You understand? So
No, I
there
don't.
is,
I do not
the
understand.
the thing that gives that direction is just the displacement ratio.
Okay,
That's
so
it.
so I explained to you what's going on with the beach ball, right?
You
What
try
I
to
think.
explain specific gravity, yes.
Well, I did explain to you what I think is happening. Okay,
Hmm.
and it turns out that we can predict how fast an object will rise or fall in a given medium.
Yep. In a medium,
Use
I agree.
Well, or in no medium at
Why
all, in a
that's my whole
vacuum
point.
chamber.
Why always in a medium?
Well, because we typically live in a medium. But if I put something in a vacuum chamber, a helium balloon, it will fall.
Yeah, why not? Why
It
won't it go
will
up?
because it has gravity, it has a downward bias on it.
No, that's the
Yes.
whole.
Oh, yes, it does.
Wait, I'm going to hold you to something.
Uh-huh.
What when you put something in a vacuum? What's the independent variable manipulated?
I don't. It could be pressure. It could be temperature.
what the hell is going on?
So
There's
not
lots of
gravity.
things it could
Wait,
be.
wait, wait. So not gravity then, because you're not.
You're not manipulating gravity. No. By the way, I think you have a misunderstanding about science. So
Oh no,
you believe that the
Don't
independent
wait,
variable must be the
wait.
cause of the phenomenon. That's not
You're
true.
gonna have to let me talk as well, Omnivore.
Well, yeah, let me just clear this up for you real quick, though. The independent variable has a cause and effect relationship with the dependent variable. You can check that. You can go look it
Yes,
up.
I've never said it hasn't. That's why I asked you. You have to actually go and manipulate the independent variable. So if you're claiming gravity, that's the
No,
independent variable that you have to manipulate.
no, you don't.
Yes, it is.
That is a flurf misunderstanding, my guy.
There is no such thing as a fluff misunderstanding. That is science. The independent variable is the presumed cause
No,
that causes the dependent variable to
show
be.
me show me the citation for that.
Okay, I'll get you 10. How's that?
Okay. What you'll see is that it has a cause and effect relationship with the dependent variable.
Yeah. The
That's
dependent variable.
different. No, a cause and effect relationship with another variable does not mean it is the cause. So,
The
for example,
the dependent variable is the effect of the
mm,
independent variable.
no. So let's say,
It's
for
the same,
example, let
right?
me explain.
If you
Let me
do not,
explain.
if you do not manipulate the independent variable, you will not be able to see the dependent variable.
Okay.
The dependent variable is based on the independent variable manipulation.
The change in it is based on the manipulation of the independent
So you
variable. But
manipulate the independent variable.
yes, but the independent variable does not have to be the presumed final cause of the phenomenon. So,
Do
for
you know how
example,
do you
if
know how hypothesis works?
I'm going to give you, I'm going to give you an example to show you. So let's say I'm testing how students do on a test, right, based on the temperature of the room, and I discovered that the cooler the room is within certain parameters, the better they perform on their test. This has been shown to be true. People do better thinking in a cool room than a hot room. I am varying the temperature and I am checking the test scores from the students. However, I would not say that temperature causes test scores, good or bad. I would say that it has an influence on test scores. The ultimate cause of test scores is going to be the students themselves.
No, okay, let's try this again. What is the hypothesis?
The hypothesis is that students do better in a cooler room than in a hot room.
Okay, so the independent variable would be temperature.
Well, actually, yeah, but not the cause of a good or bad test score, just an influence.
Yes, that's what your hypothesis just stated.
Yeah, but that they tend to do better. That they have an average chance of doing better.
No, that's the independent variable, is the temperature. Now, what would you go and manipulate in your experiment to validate that hypothesis?
The temperature, and I would check the test scores.
Great. So if the temperature changed and they did do better or they didn't do better, did you validate that hypothesis now?
Sure, yes.
Great. So the independent variable was the thing manipulated.
That's right. However, it is not the ultimate cause.
You said you would give me one where you don't change the independent variable to get the dependent variable. You just told us you got the dependent variable based on manipulating the independent variable, making my case.
Wait a second. So, right. So manipulating the independent variable doesn't have to be I don't have to independently manipulate gravity. That's your misunderstanding. I can manipulate things. Just listen to me. I can manipulate things.
Whoa. You want to push gravity as science where there is no hypothesis, scientific hypothesis and experiment for gravity to
there
ever
sure
be.
Is. There 100% is.
Where?
So we can look at modified Cavendish. Very, very clear.
Cavendish is not an experiment.
It is an experiment. It's absolutely an experiment. The independent experiment is the amount of mass that you use to attract.
Gravity. That's not gravity.
Yes, it is.
No. What's gravity?
Gravity is the effect that mass has on space-time.
No, that's not gravity.
Oh, okay. Gravity in Newton's formulation, it is an attraction between masses.
In space-time, it's just a concept. Just a concept.
Yeah.
You can say that, but we have a lot of good evidence for it. So
evidence for space-time.
Okay. Oh, yeah.
Let's do a hypothesis for this then. Okay.
So in the Cavendish experiment, I don't know if you know how the Cavendish works.
I know 100% how it works.
Okay, so the independent variable is either the mass of my attractive mass or the distance of it from the ball on the torsion wire that I am attracting.
Okay, sorry, what's the IV? Say again.
The mass of my attractor.
So mass is the IV. Okay, what's the DV?
The DV is the amount of tension on the torsion wire. I can't believe you don't know this.
No, I'm doing your hypothesis for you, showing you that it's not the scientific hypothesis.
I hope. Okay, good luck.
Okay. DV is amount of torsion.
Yep.
Okay, let me put this on screen quickly so everybody can see. Dude, I've been through this many times. Not the first time.
Right, and I understand, and you've misunderstood it each time it appears.
Okay, so we're going to say again, your IV is mass.
Yep.
Your DV is the amount of torsion.
Yep.
So where's gravity?
Gravity is the attractive force that creates torsion based on mass.
No.
Yes, it is.
You claimed Cavendish is the cause is gravity. Now you're giving me the cause as mass. Is mass gravity?
Gravity is an effect of mass.
No, it's not.
We don't have gravity without mass. Yeah.
Whoa. Yep, what's mass?
Mass can have a lot of different definitions. It's generally measured in kilograms. However, the one that I most like here is a measure of inertia.
It's resistance to inertia.
It's not resistance to inertia. It's just
That's
inertia.
also one definition for mass, resistance to inertia.
Well, no. Inertia is resistance, so you're wrong about that.
That's
a fast then, gravity or mass, because you need gravity to make mass, according to you guys, and mass for gravity. So it's the chicken and egg thing when it comes to gravity.
No, it's not. It's not at all. So you agree that we do see a increase in tension on the torsion wire that is proportional to the mass that we use. You don't agree with that. So you don't agree with the findings of the Cavendish experiment. Oh.
Again, you claiming gravity is the independent variable. Okay?
No, I'm not claiming gravity.
So then gravity is not. Then you can't use Cavendish
as an
experiment for gravity.
Yes, I can. So
it's torsion. Wait, can I talk for more than 2 seconds? Torsion. The torsion bar is showing torque based on the masses and the distance between them.
Correct.
That's not gravity. That's called torque. That's called torque. It's physics.
So
now the thing is,
okay.
Not tell me what's what. You claim that gravity is the cause.
I'm explaining
Where
to you,
is gravity the cause if your independent variable is the mass?
Okay. The gravity is the name that we give to the attractive force.
There is no attractive force.
So you don't think that Cavendish detects an attractive force?
No, there's no attractive force.
So, okay, but that means you just don't believe in the results of the experiment.
No. I can show you experiments because science is about repeatability and validation. I can show you experiments where they go the opposite way or where nothing happens or it goes chaotic.
Well, I can.
Wait. The thing is, you just made a claim that Cavendish is a scientific experiment for validating the hypothesis for gravity. Yet the IV is not gravity.
Doesn't matter. That is your misunderstanding. No, it absolutely.
You can't just claim it's something that it's not. Your IV is always the presumed force. So can you show me?
That's not true. Show me that you think it's okay. Show me where you think it's a presumed force. That's not what it means. That's not how the scientific method works.
Variable is. It's a presumed cause.
No, it's not. It just has a cause-and relationship with the dependent variable, which this does. The amount of mass proportionately reflects the amount of torsion. What you're doing now is you're dodging between.
I'm not dodging anything. You haven't given me what you said.
You're 100% dodging, and let me explain why.
You have not given me gravity. You've given me mass. Mass is not gravity.
So the reason why you're dodging is because you slip from being.
No. I'm going to stop you now. Is mass gravity?
From being admitting it does have an IV, you just don't like it.
Is mass gravity?
Yes. Mass is
No,
the
it's
cause.
not.
Mass is the cause of gravity.
Mass is not gravity. Can you bring me one citation that says mass is gravity, please?
I would say that I could bring you citations that mass creates gravity.
Oh, so gravity is not the cause then. It's mass that causes gravity. Is that what you're saying?
Yes, gravity
Okay.
is the
So
effect.
Cavendish,
Mass,
guys, is not an experiment that validates
so
gravity. It validates mass.
if you think that you if you think that that's the correct way of saying it, I'm okay with that. But what the fact is, what you get out of Cavendish is the gravitational constant.
You don't.
You do. So
They
now you're
tell.
now
Oh,
you're
wait,
now
wait.
you're
What
dodging
happens?
back to
Wait,
you're dodging back to
wait.
claim the experiment doesn't work.
If I can do the Cavendish experiment, as you put it, and it gives a null result, that means it has now been not repeatable, therefore invalidating your hypothesis.
Okay, so if you can't do it correctly, that's true. However, it turns
Are
out
you
that
like if that says if it doesn't show the desired result, therefore it's not done correct? Is that what you say?
I'm fine with you falsifying gravity if you
That's
think you can, but we both know you can't. So by
you
all
can't
means, go
prove it.
ahead.
You
Whole
can't
point
prove
is,
it either.
yeah, the whole point is you haven't gone to validate gravity yet to say it's falsifiable. You
I have.
saying no,
I have.
no. You've
Yes.
given Cavendish, which was meant to calculate Earth's mean density. It was a demonstration, not an experiment. Okay, you're not
So
even giving the correct
so
independent
so
variable.
so no, it
So
is
I'm going to ask
100%.
you, I'm going to ask you again. Can you give me an experiment, an hypothesis that says gravity, please? That gravity is the independent variable.
So there, you do not need gravity to be an independent variable. That is a mistake that you are making,
Eh,
and it's a pretty much a constant one. Here, I'm going to share my screen if I can.
Okay, share screen.
Yeah, let me see if I can do this. Okay, Cavendish in a vacuum. So this is a experiment that was done a little while ago, a couple of years ago, I think. I don't remember exactly. But what they did was it's a modified version of Cavendish where they have a Faraday shield. They use
You mean
lasers
like
to
blue?
detect the
You mean
torsion.
like blue? Like blue, Billy Blue Balls, he did it.
Yeah.
What the?
We name him Billy Blue Balls. He did it in his
Oh,
shed.
well, whatever. This was done in a vacuum chamber. It used Faraday shielding. Everything was grounded, so it gets rid of all those lovely electrostatics that you guys like to think about. And
I didn't say anything about electrostatics.
I know. I'm just letting you know. Just
We
getting ahead
don't
of the curve. That's
we don't
fine.
ascribe to electrostatics.
That's good. You shouldn't. Right. Electrostatics is easily debunkable. So
Good.
what
No,
this is this is the
electrostatics more
citation.
scientific than gravity. Electrostatics, it can be manipulated. Gravity can't because gravity is not
Right.
even a independent variable. So that's
Right. I know
false.
you. That's what you believe. Show me
No,
your
no,
citation.
I
Show
can
me
show
your
you
citation.
science where electrostatics is a thing. You can't show
No,
me
no,
science
no, no.
where
That's
gravity.
bullshit. Show me the citation that says that the independent variable must be the cause of the phenomenon.
Okay, getting it for you.
Can a fraudster address something? Fraudbuster. Go for it, Fraudbuster. Oh.
Who's
Yeah. He just put something in chat. He said he would like
they
to.
can easily debunk electrostatics?
Oh,
Hello.
it's you, is it, Roger?
Super
I'm
easily.
in here. I
Is
didn't
it-
put that in there.
Oh, you
Yeah,
didn't
I'm-
put that in there. Okay, I thought that was you.
No, that was him. I've seen this experiment already. Yeah, it's the constant rate that the torsion bar actually twists towards each mass. Is that what you're talking about? Gravity
It twists towards the mass
in the vacuum
of
chamber,
Yes.
and that's a natural experiment, right?
Yep.
No.
That happens in nature everywhere, dude. There's
So-
vacuum
so
chambers and
it-
torsion bars just sitting
So
around.
it does it well. So this is
Yeah,
another
sure,
misunderstanding. Let me explain to you.
This is not a misunderstanding. I know what you're
It
doing.
is. It is 100% a misunderstanding.
Can
So
you explain
the
more?
attraction happens everywhere in nature. We just don't
Where?
have a vacuum chamber and Faraday shield everywhere in order to
Because it's not
isolate
natural.
the attraction.
Because
Doesn't
it's not
matter.
natural.
That's another misunderstanding.
No, it does matter because you're doing natural science. To do natural science, you require nature.
No, you do not.
Yes, you do. Anyway,
that's not, wait. So you're wrong about that.
No, I'm not.
How?
Yes, you are. So you're wrong about natural. You think natural science means
you're not going to tell us you're wrong if you don't even know what independent and dependent variable is.
I do. I 100%
do. I got a few citations up for you quickly. Okay. First one: the independent variable is the cause. Its value is dependent of the other variables in your study. The dependent variable is the effect. Its value depends on the changes in the independent variable. So you manipulate the independent variable.
They're talking about a cause and effect relationship between the two variables, not the cause.
So manipulation of independent variable to get the effect of dependent variable. Well done.
No, so they are. Here you go. Here.
What is the independent variable? The independent variable is the one that is changed by the scientist. Why just one? Well, if you changed more than one variable, it would be hard to figure out which one change is causing what you observe.
That is 100% right, but the observation is in the dependent variable. It does not have to be the cause of the phenomenon. That is a misunderstanding. Here, I'm sharing a screen now that shows the first thing I pulled up on Google.
Google. Look nice.
It's literally saying it on screen now. The independent variable is the one that is changed by the scientist.
Correct.
So if you change this independent variable, will you get the dependent variable?
You will change the dependent variable. There is a cause and effect relationship between them, but that does not mean that can be by changing the distance of the mass or by changing the amount of the mass. Those are both perfectly
fine. I'm going to ask you very simple. Is it the independent variable or independent variables?
Independent variable.
One. So when you make a hypothesis and you want to figure out a cause, you use one IV, correct?
That is one way of doing it. Yes.
No, that's the way of doing it. That's
you don't necessarily. So you're
so pseudoscience.
No, not pseudoscience. This is perfectly standard, ordinary science. You can tell by reading the descriptions that Flatzoid has pulled up that you're wrong about the independent variable having to be the ultimate cause of the phenomenon. You're just not right about that.
Okay, so in the Cavendish.
Yeah, the independent variable, the variable that is stable and unaffected by other variables you are trying to measure. It refers to the condition of an experiment that is systematically manipulated by the investigator. It is the presumed cause. You told me it's not the presumed cause.
So what it is, the presumed cause is the effect on the dependent variable. The silica fiber, the torsion of the silica fiber is the dependent variable. The distance,
it's not. Yes, the torsion of the
That's the silica fiber.
So let's go back to again. To get back to your hypothesis. So the independent variable is mass.
Yep. This
not gravity.
You can say that, and you can think that means something, but you have
it does.
Well, let me explain what
you want this to be valid.
So don't run away from this.
I'm not running away from it. I'm running into you, dude. You keep talking over me.
You're running away from it
now. What am I running away from right here?
You're the one who's blah, 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 blah.
I'll explain.
Slow down, dude. Relax.
How can anybody run when you're just blah, 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 blah?
You're running away. Yep.
How is that running away when you're the one talking?
No, running away from what, dude?
You're running away from the fact that the Cavendish experiment observes an attraction. There is an attraction.
No, it doesn't. I can show you the Cavendish done where it does not show any attraction. It shows opposite. It shows repulsion. I can show where it goes chaotic. I show where it shows nothing. That's total nonsense.
No, that's not true. 100%. It 100% does. And this, I've put my citation on screen.
Why do you always have to do this? Why, whenever I give a statement, you talk over me? Exactly. I'm going to say this. You started off with telling me you have a scientific hypothesis and experiment to validate gravity.
Yep,
I do. Not given one. Cavendish is not about gravity; it's the mass, as you put it.
This is the measurement of gravitational coupling between millimeter-sized masses.
You talk over everybody.
Omnivore.
While you're talking, Flats, because he's just not listening. He's just
You had a
talking.
back and
Every
forth
time
before?
you talk, he talks. So you got to mute him when you're talking. Nobody's got to hear a word you're saying.
Yeah. Let's just try it one more time.
Cool.
Omnivore, you made a claim that you can give us a scientific hypothesis and experiment for gravity, not for mass. Mass is not gravity. So, would you please concede then your hypothesis is not gravity, or will you just give us one that does have one for gravity, please?
So I've already explained to you, and you should know this. What this paper establishes is there is an attractive force. You claim there's not, but this citation proves you wrong. Unfortunately for you, and that amount of attraction, it turns out, is directly what we would calculate from the universal gravitational principle of Newton, or from relativity. Turns out that this is good evidence for gravity. You're going to have to jump between it's not science and there is no attraction. Those two things are not related. If you think there really is no attraction, I can show you numerous experiments that do show the attraction. So,
Okay. Again.
So don't claim it doesn't work.
Wait. Is science repeatable?
Yep.
If you go and do the science and it shows opposite of that, it has invalidated it. You only need one to invalidate a hypothesis.
Not necessarily, no.
Yes, necessarily, because that's not the cause.
I can explain. No, I can explain this to you. So,
sure you can.
Just having one, if I set up an experiment and it doesn't show what what my hypothesis thinks it should show, and I repeat that experiment and it consistently does not show that, then yes, it invalidates the hypothesis. However, in this case, this experiment is done all over the world, all the time. School children do it in colleges and things like that. And yes, it does produce the attraction. This paper shows it. This paper shows you.
No. I'm going to tell you again. Cavendish wanted to calculate Earth's mean density. He didn't do it as first of all. C.V. Boyes attributed to him later on. Okay,
I'm well aware of this line of nonsense. This is nonsense.
Newton didn't want to describe gravity because he founded absurdity. Okay, Cavendish was sitting with a telescope in a shed. Correct?
Okay. I'm sharing the screen of what I'm talking about.
What was Cavendish trying to do?
Show what I'm sharing. Put that up on the screen. There you go. This is what I'm talking about. This was done in 2021. This is done in 2021. Okay? So it was not done in a shed. It was not done by a guy named Cavendish.
You know which one this was. We actually were laughing at the guy that did it.
Well, you can be laughing all you want, but this absolutely shows
nothing happened until he went into his garage and actually bumped the apparatus.
In this case, no. This isn't in the garage.
We watched it live. It was a live stream.
This is not in the garage. I'm showing you this thing right now. No, you have not seen somebody do this. Okay? This is done in a vacuum chamber.
Yes, he did in a vacuum chamber.
And with a Faraday shield and using gold balls.
And a laser and a mirror. Yes.
I promise you haven't seen this.
Did Billy Blue Bulls do this exact same thing?
No, he may have done something similar. But
no. He did exactly that thing, and we watched it live. It was like,
well, look, Flatzoid. If you think,
dude,
can I finish talking? And the thing is, when nothing was happening. He actually had to go into the shed and cause it to make something happen.
So
can you
have
every 2 seconds? Getting irritating to close private chat, man.
I'm sure.
Thanks.
This is absurd. Yeah, you're right. This is absurd.
Looked at Cavendish actual paper before.
Why? He just asked you to stop doing that, and you said yeah, sure, and you're still doing it.
Doing what?
Writing in the private chat.
Oh, I'm typing in the private chat because you guys don't want to.
You don't want to hear what I'm saying. You're the only one talking. Wow, you can't say we're not listening. You're the only one talking. When Flats tries to talk, you just talk all over him. Will you stop writing in the private chat?
Still doing
No. No,
Well,
so
go then.
Go ahead.
Then.
I want to respond to Flatzoid, and
well,
I can't
respond
do
to
that.
Flatzoid. You don't have to respond to him in private chat.
I am responding to Flatzoid. So you're wrong about what Blue Marble Science did having anything to do with this. I haven't seen it.
Blue Marble Science.
You know, I know that you're desperately holding
Blue Marble Science, guys. Okay, so actually he has been around, and he does. This guy's just trolling us.
Yeah.
No,
of course he is.
Because first of all, I'm going to say this again. You have yet to show me a scientific hypothesis and experiment for gravity. Stop bringing up Cavendish, which has nothing to do with your claim. You gave an IV for mass, not an IV for gravity. The independent variable is always the presumed cause for your dependent variable. Your independent variable is not gravity, so the experiment you're trying to present is not gravity.
You're wrong about that.
For gravity.
You're wrong about that.
Talk with the bloody private chat.
You're wrong about that. I'm letting you know that you're wrong.
Yeah, but you don't need to write in private chat. You can talk.
I can't talk because then I'm talking over him.
All you do is
talk. My goodness. All you do is been talking.
All right. I'm telling you you're wrong about IV and that this is a perfect experiment and that the fact that you saw something weird happen on Blue Marble Science has nothing to do with this.
Well, I'm telling you, you're deluded.
Well, you say I'm deluded, but I'm the one who's got a citation here.
Yeah, you're also rude.
That's brilliant. Fantastic.
You're so rude.
That proves everything.
There you go. You've got. Would you like to see the one they did with several tons of liquid mercury and steel bars? I can bring that one up.
I'm sure it's
have you realized you haven't once actually just answered what I asked for? By the way, do you know that these oscillations are just based on averages because they're always different?
Yeah.
So, not a constant. The constant is an average.
All measurements have what's called a margin of error, which you should know. And that means that you're not always guaranteed to get the same thing to 4 or 5 significant digits every time. But if you do repeatable experiments and all of them cluster significantly around a certain number, then you have a statistically important, finding. That's how.
Okay, so I'm going to ask you again. So I'm going to ask you again. If you have a constant for your gravity,
it's a universal gravitational constant.
Well, would that constant always stay constant?
Presumably, yes.
And does it always stay constant?
Presumably, yes.
It doesn't. That's why it's an average.
You claim that, but
even if you have the same controls, you can have all the controls the exact same. You can change literally make it exactly the same as what it was and repeat it. It gives different results. That's why it's an average.
No, it doesn't.
Whoa. So is gravity fluctuating?
Okay, there's two things that you need to. I know this is confusing. So the gravitation, you are entirely.
You're confused because you don't know when to shut up.
No, he's just a tune.
You talk over everybody. I don't even know you are. Obviously, you think you're some dinosaur.
Omnivore's been around for a while.
No manners. You are vile.
You're a tune tag. Simple as that. Tune sent him over.
He is though. Listen to him. Like. Your ego is massive, mate. Massive. You are just another glow card piece.
I'm just going to make
really
it. If you could actually respond to what I'm saying, you have a point. But you.
Okay, I muted him so I can make.
If you could shut the fuck up when people are talking.
Babe, language.
He's a twat.
Language, babe.
Sorry, I'm going.
Okay, I love
you. He needs to shut up.
Love you.
Yeah.
Anyway,
I'm making my statement quickly, so I muted him because I don't want to debate the guy that doesn't even understand what an independent variable is. Okay? So the statement is straight. Omnivore, you came on, you made a claim, you are unable to back it up. You made claims saying, I don't understand, when I literally bring up citations showing you don't understand. I am explaining to you, you do not have an independent variable as gravity for your claim, therefore it is false. Now, I'm done debating you because you obviously don't have any humbleness to just concede that you're wrong and you can't actually show truth for your gravity belief system. Where I can show you actual scientific evidence for displacement. It's called Archimedes' principle. And no, Archimedes' principle does not need gravity. It was actually done 1,900 years before gravity was even postulated. You do not need gravity for things to fall. That is your belief. Until you can actually provide a scientific hypothesis and experiment for them, until then it's just a belief. Now I will leave it to the rest of the panel to debate you, because I clearly don't need to debate a guy that doesn't know what an independent and a dependent variable is.
This guy really thinks science is things like technology is science. He's not even worth it. Somebody just said in chat, he's a chat scan from FED. So he's been sent from McToon or FDFE or somebody. Oh, that's lovely, Link.
No, it doesn't, dude. Archimedes' principle uses gravity because of the what?
Because of rho GV, but that wasn't there. Archimedes' principle was made 1,000 years before gravity was even postulated.
Do you think boats didn't float before gravity was invented?
There was no gravity.
It's invented. Yeah, I know. They didn't need it.
Somebody invented gravity, didn't they? It was invented, you're right, in someone's head.
No, it was invented as a result of observation. I know you want to. Yeah, you want to talk over me. I understand that. I get
You're the one that's talking over everybody. So
no, I'm not. When I type in the chat, you can't talk over me.
You do not have anything.
And you
nothing new. Nothing new.
So I'm going to explain this to you again. The effects of gravity are observed without having to have a name for it. We had boats work long before Newton formalized the gravity. However, it turns out that in order to calculate how fast something rises or falls in Archimedes' principle, you have to use the gravitation of 9.8 meters per second because, as I said, the buoyancy is the effect of gravity pulling everything down. Everything has a downward bias. And more massive, and the more massive things, that's why, air does too, right? You can get one of those. Yeah, it does. You can get one of those barometer apps on your phone, your smartphone, and you can.
I have a barometer. I don't need a barometer app, dude.
Well, you can show what's on your camera. You can do it right now in front of us. How the air is denser at the bottom of your office than if you hold that very sensitive barometer up to the ceiling of the office. You will see that it's denser down below. Magically denser.
Magically. Oh, yeah. So.
Well, it's a downward bias. Yep.
Okay, so this affects gas too, right? You're going to tell me that.
Right? So I just told you could use a barometer app, right?
Sure. Yeah, barometers actually prove that. It has nothing to do with anything else, right? There's no other variables in there. And just gravity, right? Yeah.
No, there's other. Well, I don't know what you mean by that, but I think that. It doesn't make any sense.
If gas has a downward bias, if I open a container, it automatically goes down.
So I see your misunderstanding. No, well,
it's not a misunderstanding. I'm making an
observation. Yes, you are. Yeah, you're misunderstanding. So gas is a collection of very high kinetic value kinetic energy molecules or atoms. So they're all moving around pretty quickly, and they are not coupled together like we find in solids and liquids. However, although they can have a directional motion in any direction, all of them have that little bit of force pulling them down. They don't necessarily go down because you can have forces pulling you in more than one direction, or you can have velocity or momentum going in any other direction. However, you will find if you use your barometer app that the gases in your office is denser at the floor than at the ceiling, and you can go do that outside. You can do that.
That's all. There's more gas bottom. It doesn't make gas go down, go boom, boom.
Wow. Yes, it does. Unfortunately for you guys, it does.
If you can show me one gas molecule standing still, I'll eat my hat.
I'm sure you would. What it shows you is that there is a stochastic tendency for gas to be denser further down. And this is a gas?
I think break it down. What is a gas?
Gas is who's asking this? Is this Flatzoid?
Does gas?
His name's Flatzoid, dude.
Yeah, does gas?
Flatzoid. I thought we were calling people by other names because of blue marble science. We're not doing that?
What?
What I'm asking you, you know, if gas stops moving or not. That's all I'm asking you.
Why are calling blue marble science by a different name? I thought that's how we were doing it.
Blue ball.
Oh my God.
Okay. I got it. So you can do it, but not me.
Stop moving. Can you show me gas ever stop moving, please?
Yes. When we take gas and we freeze it.
You don't get 0 Kelvin in nature.
Wow.
You don't get 0 Kelvin in nature. Heck, we can't even recreate 0 Kelvin.
So it doesn't. We don't have to create 0 Kelvin.
You do. That's the only. You have to create 0 Kelvin to get a gas to stop moving. Thank you. You have been shown once again to be not.
Let me explain.
No.
Yes, I can explain what you're wrong about. So when you freeze a gas and you transition it from the gas state to the liquid or the solid phase, although yes, there is still slight Brownian motion in solids, there is absolutely not the same degree of motion that you find in a gas. It is entirely different, extremely different, and that is you don't.
Can I ask a real quick question here?
Zero.
Okay, when the gas is frozen, is it still a gas?
No, it has transitioned to liquid or solid.
Okay, so there you go. It's no longer a gas, so you can't show us that a gas has stopped moving.
Well, a gas doesn't stop moving. That's defined by being a gas.
Oh my goodness!
Yeah, I mean, I explained that to you. No, I explained to you that the gas has molecules moving in all directions, but each of those has a slight downward bias, which is why you get higher density closer to the surface of the Earth than you do higher up, which you all know happens.
Concentration of gases is not gas go down, go boom, boom. Told you.
It is. I'm sorry, but it actually is.
No, it is not. Can you please bring me a bucket of propane?
Bring a what?
Without containment. No containment needed. Yeah, we need a bucket of propane.
When you say no containment, you mean no physical containment, right?
Yeah, that's exactly what we're talking about.
Because I can show you magnetic fields containing gas.
Magnetic field containing gas it's ionized gas, not gas. You can't use magnetic fields to go and contain more gas if it's not ionized.
So
you know that.
So I'll give you. Okay, so I understand you don't like.
You know how ionized gas is
like what,
not a normal gas.
I do.
And it's a different state of matter.
Like it. I understand you don't like it. Okay.
Why don't you shut up and get on with what you're going to say? You don't like it. No, it's just not true.
Saying I don't understand when I'm the one that has to stop you and educate you every time you open your damn mouth.
Have if you understand, I gave you a link that you can look at to learn about IV and DVs.
You have.
I know you won't read it.
Gravity yet as an IV.
Yes, I did. Yes,
you have not given me an IV for gravity.
I did. So
you gave mass.
The reason why, but the reason why you're hiding from this.
Gravity.
You are
get off your little big boy shoes now and be a man.
You are hiding from this.
Not have gravity as science. It's as simple as that.
So let me explain why it's not. Why you think it is, or why you think it has to be. What you are doing is you are trying to claim that there is no measured attraction. That is the ultimate hill you have to try to die on. Otherwise, you're fucked. Because you know that the science shows there is a attraction force.
There is no
repeatable. Yes, there is. So there is an attraction. Right. So this is where you break.
Give me the science for gravity.
This is where I break you. This is where I break you.
This is where I break you. Look at the hubris from this guy. He's absolutely ridiculous. This is where I break.
Talk one at a time, guys.
Yeah. Just give the science for gravity. Don't make a declaration. Just give the science for gravity. You have failed so far just to give an independent variable for gravity. You have.
No. Yes.
Where?
So gravity, first off, do we agree that there is an attractive force detected?
No.
Okay, wait. So I have shown you a citation for it. How do you debunk that citation?
With experiment that proves your hypothesis.
So that doesn't work, unfortunately, because I have an experiment that does prove my hypothesis. So the fact that you've got one that doesn't...
So it's not repeatable in all cases.
It is 100% repeatable. This has been repeated.
No, this is what peer review is for.
This is a peer-reviewed paper.
When you go and do a peer review, you are replicating the experiment. If it shows to not do the same as the claimed validation, then it means it is invalidated. Do you understand it? Only need one.
No,
only
you
need
don't.
one.
No, you don't.
Only need one to show that it is invalidated.
That is not true.
Yes, it is. This is science, man. Your
belief. I'll explain why. I'll explain why.
Your belief system has no ground in science. I muted him again because he doesn't shut the hell up while I'm talking.
He doesn't.
So omnivore, I'm going to unmute you again. Show an independent variable where gravity is the independent variable in any experiment. Just one. I don't want to hear you don't understand, want to call names, blah, blah, blah. Just present an independent variable where gravity is the independent variable for your claimed experiment. Just one. Guys, you all heard this very clear?
Yeah.
Great.
Yes.
Now I'm unmuting you. Go ahead.
Okay, so you're wrong. I'm sorry, you're just wrong. So
okay.
you can't.
Because I just said, I don't want to hear you don't understand, you're wrong, blah, blah, blah. Just show me, I'm going to try this one more time. Present a scientific hypothesis and experiment where gravity is the independent variable. Don't want to hear anything else. Just present. That's it. Not hard to understand. Just present.
Okay, I am sharing my screen. We're going to talk through this, and then you'll run away from it.
Oh, shut up. Stop being an idiot, man.
All right. So what they're doing here is they have a setup that does a very good job of isolating all other known forces, right? It isolates, electrostatics, magnetics, it isolates vibration, and it isolates everything else. Casimir forces, they chose sizes for Casimir forces. So this isolates all the other bullshit. And what we find here, this is a peer-reviewed paper. It was quite popular when it came out in 2001. And you can see acknowledgments. And if you go search for it, you'll find that it has a lot of citations. So what this does is it shows that the predictions made by the theories of gravity are validated. So you don't like it, but it does validate the theories of gravity because the amount of attraction is proportional to the masses in the way that the universal law of gravitation says they should be.
Okay, I don't know. Maybe I should speak another language. I want an experiment where gravity is the independent variable.
You don't need one. You have attractive force. The force is
you are trying to provide gravity is the cause for attraction of masses.
Right. And we have two masses.
Independent variable.
Mm-hmm. We have two masses.
Gravity is not the independent variable here. Therefore, gravity is not the cause for this experiment you're claiming.
So what do you think the cause is? What do you think the cause is?
You're saying mass. Not
okay. So you think mass is the cause of the attraction?
No, I don't think anything. I don't
so
think
I know you can't engage with this experiment.
You're making it. It's not a damn experiment for gravity. I'm asking you again.
This experiment wrecks you.
Provide me.
Okay.
Go and provide.
You believe it does.
I know it does.
No, you don't. You don't know shit. You know nothing.
So in this case, the attractive force has a cause and effect relationship, with the proximity of the test mass has a cause and effect relationship with the attractive force measured on the torsion wire. That is all you need.
Let's put it this way. So if I change the mass, it changes the outcome.
Yes.
If I change the distance, it changes the outcome.
Correct.
If I change the density, it changes the outcome.
Could.
If I change the medium it's in, it changes the outcome.
Not necessarily.
Yes, it does.
Not necessarily.
Yes, it does.
Well, what you do is you'd have an additional factor, but doing it in a vacuum.
I'm going to quickly debunk everything you've just said. What happens if you
can't debunk anything. Oh my God.
If you put an object on a scale in a vacuum, does it get heavier?
If you put an object on a scale in a vacuum? So you can actually, so it depends on how you have the scale set up.
It's a yes or no question. Does it get heavier or lighter in a vacuum?
If the scale has air inside it and is not completely sealed, then
this guy's just dishonest. He doesn't want to just admit it's relative density.
What you get?
I cannot present to us anything for gravity. Thank you for playing Omnivore. You can't provide any evidence for your belief system.
This experiment 100% does.
Okay.
You can see it right there. We could read through it, and you could say, "Oh, gosh, they really are experiencing."
You got to say and type it at the same time, dude. Stop.
Type it. You said the exact same thing saying it orally as you did typing it.
Well, it's right here. We can talk through it. So the last decades have seen numerous experimental confirmations of Einstein's theory of relativity, our best working theory of gravity, which is true. We see all sorts of things that are effects of gravity. We see things like gravitational lensing, the Einstein circle, and the Einstein cross, where we look at things far distant in the cosmos. We see things like time dilation when we do an experiment.
We do
an atomic clock. So a bunch of students and Air Force Academy cadets did an experiment with an atomic clock at Pikes Peak.
We know this,
mountain you may have heard of. I don't think you do. So they took the atomic clock from the base of Pikes Peak to the top of Pikes Peak, and they observed the amount of time dilation that they would expect that relativity predicts. Are you familiar with that experiment?
So not force then. Relativity is not a force. Well done. So just debunk Newton. Thanks.
No, so we haven't.
Jeff Conkle, thank you very much for your $5 super chat. It says John 1:1. In the beginning was the Word. The Word was with God, and Word was God. Amen. 100% agree, man. Really appreciate it. Super chat, you rock. So yeah, not in the beginning was gravity. It was God. I agree.
No, I am religious. I am a Christian.
Well, I'm religious, but I'm a Christian.
That's amazing, dude. That's amazing to hear you're a
Christian. Well, so you're a Christian, Omnivore?
I am.
Awesome. So how would you, I'm sorry to say, but how would you read Genesis 1 as a globe then?
So I read it the same way that I read the Psalms. Reading the beginning of Genesis, I believe that it covers the spiritually important parts of the creation of the earth and all around it, and that it explains it in a way that is spiritually relevant, the same way that all the rest of the book.
So you don't believe Genesis is? You don't believe that Genesis is historical narrative?
I don't believe it's literal narrative. No.
So, in other words, when God spoke to Moses,
hello everyone.
Hey Jonas, good to see you, man. So when God spoke to Moses, and he told him how he created everything, you think it's not literal?
I see no reason why it would necessarily be literal.
Do you believe in evolution and the Big Bang?
I believe that those are the best explanations we currently have using our God-given intellect. So we have intellects.
That's all I needed to know. That's all I needed to know.
That God gave
Omnivore,
us.
can I ask you a question?
When we use those intellects, yes, go ahead.
Could you please provide one example when something can be created out of nothing, please?
So I believe that God is responsible for the creation of the universe and everything in creation. So that would be my example.
Okay, please show me one example from the history. Probably you claim that the Earth is billions of years or whatever. Please show me one example when non-life created life.
So you're talking about abiogenesis, which is different from evolution or the Big Bang, even though you guys try really hard to lump it all together.
I'm asking a specific question.
Yeah, I know. I'm explaining for the audience. I'm explaining for the audience what's going on here. You want to talk about abiogenesis, okay?
But no.
He's talking about the big.
Provide your claim. That's all. He's not talking about abiogenesis. You are trying to reverse the burden onto him now with abiogenesis.
No, he is talking about when he talks about
life. You just said you believe in evolution.
Life
you said you believe in evolution.
That's different from abiogenesis.
He's asking you.
Omnivore, please listen. I asked you a very specific question. Please provide one example when we can observe that the non-life created life. It's a very simple question, very basic question.
Yeah. Okay. I do not have that example, and I have no opinion on abiogenesis. I think that evolution is something that we can observe. I think that the creation of the universe...
observable. Prove observation. There's no observation of evolution at all.
No. So I think we all agree that microevolution happens, right?
No.
So... okay, so
adaptation is not evolution.
Adaptation, not evolution.
Adaptation, mutation is not evolution.
Okay, right. Just one last question from me.
I understand. I know the dance.
Just one more question from me. Last one. Omnivore, could you please tell us what gravity is?
So the gravity is the attractive force between two masses, or multiple.
No. I'm asking you what it is. Don't describe it. I'm asking you what it is.
So I don't claim to know what it is. Neither did Newton. The description that you're hunting for, that you think is the gotcha, is that I would describe it as warping space-time. However, this is because you don't understand what is meant by warping space-time.
No. I do not stand under you. I can comprehend.
You do understand. You do stand under me. Are you a free man? Are you just traveling now?
Yes, I am a free man.
Okay,
I'm a free man.
You're not driving. You're traveling.
Anyone.
You're traveling. I got it. You're gonna get that Admiralty law is gonna get you. Get your Black's Law dictionary ready.
Why are you talking about that now when he's asking you simple questions?
Yeah, we're asking a question.
Because he said he doesn't stay. Because he said he doesn't stand under me.
I'm not standing. Please listen. I'm not standing under any man. I'm only standing under God.
Okay.
It's very simple. If you are choosing to stand under someone, it's your own choice, which you have right to do. You're entitled to it. But I choose not to stand under anyone.
Right.
Only standing under God.
Well said.
Right. You don't comprehend what is meant by space-time. So
thank you for correcting yourself.
Oh, wait,
you can't even explain it anyway.
It's
not a real thing.
I can explain this. I can't explain this if you guys want.
Before you guys go on, I missed Matthew DeRoggio's thank you sticker. Thank you very much for your sticker, dude. You rock.
As you claim, Omnivore, you don't know what the gravity is. You can only describe it. But even so-called science, top scientists, they can't say what gravity is.
Right.
So how you can say that you know what it is, that it exists, if you can't even explain it, if you can't even know what it is?
So,
how you can do that? You can't.
Yes, it's quite easy.
If you try to do it, it's logical fallacy. It's as simple as that.
This is really easy. No. Let me. I'll educate you on this. That's fine.
Oh, thanks. I need education.
Yes, please.
I love it.
I apparently I have to. So
what arrogance!
Well, I mean, you guys don't understand independent definitive.
Oh, really? You think we don't understand? Everyone spewed this garbage to us. It's just
I completely understand.
The whole night, all he's been doing is you don't understand.
Yeah. Well, I'm explaining to you why. I'm trying to explain to you why.
Weight on a torsion bar actually is the cause of what you're talking about.
So the weight on the torque on the torsion bar is a measure of the attraction. Do you understand that?
No, it's not. It's the measure of torsion.
It is. So what is causing the torsion bar, the torsion on it, to increase
the weight of the object?
When the other gold ball is moved closer to it, why does the torsion increase?
They don't always move closer.
Yes, they do. They have shown this. They have shown this multiple times.
Bring up some examples where it doesn't.
I don't care about examples where it doesn't. If you can
show, don't care about
if you can dismiss those that show the exact opposite of what you're talking about.
No. What I'm explaining to you is that tests done in laboratory conditions, by people who are trying to get this very, very accurately done, consistently detect gravity. That is 100% fact. You don't like it, and so you're claiming you've seen some videos on YouTube where it didn't work the first time, and therefore you're saying, I don't think it works at all.
Okay, Omnivore, you know what? The thing is, you're always assuming gravity just to be there, and you're always just assuming it is fact. We're telling you gravity cannot be assumed as fact because it hasn't gone through the validation of science to make that claim. Now, No, it hasn't.
Yes.
You have not given me one scientific hypothesis and experiment to show this.
This is the one I'm showing you does. You just
That
have
is
to,
not.
You have to deny it.
Your IV was mass, not gravity.
Correct. The IV,
So
having
gravity,
the IV be mass works perfectly fine.
Whoa. Listen here. I'm looking for gravity as the cause for mass attracting.
I know what you're claiming you want, because you believe that it can't be provided, therefore you're safe in claiming it.
Hey, Omnivore, I got a question for you.
Stop. You're just wrong about
question. Can I ask you a question? What is mass? Can we get a definition for what mass is right now?
There's many different ones.
Mass has several different definitions. Yeah, so I would say that it is a measure of inertia. You can incorrectly call it a resistance to inertia, which doesn't mean anything. But if you take it as a measure of inertia, then you have a pretty good basis. It's going to be measured.
I'm going to take it a step further. What causes the mass? What causes the resistance to inertia?
What resistance to inertia?
Yeah,
inertia is resistance to motion, to acceleration. Do you understand that?
So how did you determine that mass is the cause of it?
So I observe that mass demonstrates inertia. When I push on a large object and get it rolling, it is harder to stop than a lighter object, for example, and harder to get going.
Okay. So how did that define what mass is, though? That's not a definition for it.
Sure it is.
How?
I mean, mass, we can say matter. Mass is matter if you prefer that. That's a very easily understood way that we understand it, in everyday life.
We do?
Yeah.
I don't use that at all, ever.
I'm sorry, that's just wrong. Mass is not matter.
Well, you can, like I said, you can diddle about whatever you want mass to be, but if you can't engage with the experiment I showed you, then you lose.
It was an experiment for gravity. Didn't. Now again,
that experiment. So that experiment shows an attraction.
Verbal ejaculator. Shut up.
It shows an attraction.
Shut up.
That attraction is called gravity.
Shut it.
I muted him again. The thing is, you just chanting the whole time doesn't make it so. It's not hard to understand. You claim gravity is the cause for things. So I'm asking you to show me a scientific hypothesis, which would mean the IV would be gravity, and experiment to validate it. Mass is not gravity. It's the same as me saying, heck, I'm going to grow an apple tree and I get a lemon tree. I say it's an apple tree just because I planted a lemon tree.
Yeah.
Is it the same thing? No, it's not. So now I'm going to ask you again. You claim gravity is the cause, so present gravity as the cause, not mass. Mass is not gravity, just like my right hand is not my left foot. Okay? Thank you.
And nobody's pretending, dude. So stop typing in there. No, we're not. I want to see.
No, just everyone. Please, everyone, shut up now and let him answer. Please.
You got it. Okay. You got to pretend that the experiment didn't work. I can show you another experiment. I can show you a dozen experiments.
That's not the question. Please answer his question.
I am answering his question. If you can't engage, the attraction is what we call gravity. That attractive force is what we have named gravity. No, so if you can't, it actually is. Yes.
You don't even know your own belief. That's not what you call gravity.
No, that's what everybody is calling. That's what everybody else is calling gravity. So wait, you can have your own.
Are you claiming gravity causes gravity?
Definition.
Is that what you're claiming? Gravity causes.
I'm saying that masses attract, and we call that attractive force gravity. Really simple, and we measure that. We measure that attractive force in this experiment that you cannot engage with.
So gravity causes gravity.
Mass causes attraction of other masses, and that attractive force is called gravity.
So again, gravity causes gravity because
try repeating what I said. I'll type it in the chat.
We know what you said, dude. No type in chat no more.
So the attractive force is gravity.
Foolish behavior, man.
Yeah. So the attractive force is gravity, which is also false because, like we said, Einstein says it's not a force, so it cannot be an attractive force, and you can't have mass before gravity because you need gravity for mass to attract to each other.
No, you don't. So
okay, then how do you have mass attracting mass without gravity?
So mass attracting mass is what we observe.
No, where?
In the experiment that I gave you that you can't engage with.
The crap in a dish experiment.
Oh, are we doing the names now? Because I was going to call it Flatzoid again if we're doing the names.
Again.
I didn't call you a name, did I?
Well,
Is your name Cavendish? No.
I just thought if we were calling people funny names, then
he's making fun of the not experiment that you're claiming is a.
It's 100%. It's 100% an experiment. It's got the independent variable of distance of the attractive mass. It's got the dependent.
You got more than one independent variable. Therefore, it's not an experiment.
No, you don't. No, you don't. It's one.
What is one? Okay. What is the independent variable for Cavendish?
In this case, in the case of the document that I'm showing you, it is distance of the attractive mass from the mass on the torsion bar.
So three independent variables.
No.
What's the independent variable for Cavendish?
Distance of mass, the distance.
So distance and mass. So it's two.
No, just distance. It's
so just distance, no mass. So we don't need to put a mass there. We just have distance.
You don't change the mass of the attractive sphere.
You just change the distance.
Yeah.
But you told me earlier mass was the independent variable. Now distance is the independent variable.
You can do it. You can do it both ways. Either way, you can do it.
Therefore, it's not a validated experiment.
Yes, it is. It's right. I shared the link with you. You can go look it up. It's 100% valid. Yes, it is.
The same result.
Peer review is garbage. That's right. That's your final fallback. You have to deny the experiment.
You get the same. I'm going to kick you, dude. This is getting really bad.
It's getting really bad, yeah.
Yeah. Do you get the same? Yeah. Do you get the same result by changing more than one independent variable?
Guys, listen.
There's only one independent variable in this experiment.
You said mass and changing distance. That's two independent variables. So in other words, it's not a validated science experiment.
I'm not changing mass. In this case, I'm only changing distance.
Listen, guys, we are getting into details and we are muddying the water. The simplicity is the beauty. Please imagine now, there is a blind person who never seen the cat and never describe to this person the cat. How this person can describe the cat if he doesn't know what it is?
The cat?
Cat.
Meow. Cat.
Yes, feline.
Okay. So a person, I don't know why the cat matters. In this case, we measure the force of attraction.
No. I'm asking the question: how this person can say what cat is if he never seen it, never heard about cat, never had description of the cat? How this blind person can say what cat is?
So are you saying this person who describes a cat gets incredibly lucky by chance?
No. In other words, how do you present a case of something to someone who doesn't know what you're talking about? So in other words, tell us what gravity is.
Okay.
As a person that's never heard of it, that's never seen it or anything.
So gravity is an attractive force between all masses in the universe. Every bit of mass in the universe exerts an attractive force, a very small one, on every other piece of mass. When we have objects with large masses, they exert a notable attraction on other bits of mass towards their center of gravity, their center of mass. We call this force, this attractive, potential, we call that gravity.
Okay.
And that will be nailed to your coffin now, because previously you have admitted that you don't know what the gravity is, and now you're trying to describe it.
I just told you what we call gravity. So
you're trying to describe something which you don't know what it is. The same as blind person who doesn't know what cat is. He's trying to describe it. It's exactly the same, man. You can't see the comparison.
We measure
you can't see force. It, really.
This force we actually measure. We measure the force.
You haven't measured it, dude.
It is. You have to deny the experiment.
Whoa.
If you guys can engage with the experiment at all. If you can engage with the experiment, then we have a debate. But if
you measure oscillations, and then calculate an average. That's not measuring a force, man.
It is measuring a force. Yes,
you're measuring oscillations.
So what's causing the oscillations?
You haven't narrowed that down.
What's causing the torque? What's causing the torque to change? What's causing the torque to change?
Torsion.
What's causing the torsion to change?
The uneven balanced.
No, they're evenly balanced
by the weight and the rod.
They're evenly balanced, and they have a laser checking it.
It's an unbalanced force. That's how torque works.
What you're doing?
It's an unbalanced force,
You're denying the experiment. It's not an unbalanced force.
I'm not denying any experiment.
You are.
The physics behind it.
I can show you on the screen again.
I'm still waiting for you to show me an independent variable where gravity is the cause for anything.
This is right here. It's this. I'm sharing my screen. You can show it if you want.
Should we move on to the three-body problem?
Yeah, man.
Why does the three-body problem not work with your claim?
The three-body problem does work with the claim. There is not a...
It's unpredictable.
Let me explain the three-body problem for you. No, you can solve three-body problems. You can solve three-body problems. There is just not a general solution for three-body problems.
There's not been a solution for it. It's an unsolvable hypothetical.
So it's not. There are solutions to the three-body problem. You guys are
unsolvable hypothetical.
So you don't believe me?
False. There is an unsolvable hypothetical. Do you know what the chaos theory is?
Yes.
Butterfly effect.
Theory.
Yes, I do.
Theory.
Is that solvable?
It is.
It isn't because it's unpredictable. Do you know what unpredictable means?
I do know what unpredictable means. I'll put a link in the chat. This is a link in the chat.
I gotta go, dude.
Mathematicians find 12,000 new solutions to quote unsolvable three-body problem. I'm terribly sorry, my guys. So I'm going to have to drop. I have this experiment. If you can figure out a way to engage with the experiment, acknowledge that it's a citation that you have seen and tried to deny, then we've got something. Then we got something to talk about. Otherwise, I guess
I'm going to ask you something. For this solvability that they did there, were they using classical physics or were they using other type of hypothetical things like chaos? Well, what was those things that I brought up earlier, Matt?
The butterfly effect. This is an actual.
I was trying to get the specific wording quickly. Sorry, I'm just getting specific wording. Before I speak my foot in my mouth.
Well,
it had to bring up.
You have a link there that you can look at.
Is electromagnetics part of gravity?
Doesn't work. Nope. And I have to drop. Okay. Not electromagnetic.
Is special relativity part of Newtonian physics?
Generally not. But you can read up on this. If you read up on this before I come back, do some of the background reading.
The theory of random walks.
You're deluded.
Newtonian physics.
Deluded. He's deluded. See, who's the runner? You're deluded, dude. You're just another chanter. Just another chanter. He's going to be deluded for life.
Oh, he ran away.
Yeah, he ran away. That's what I'm saying. He's going to be deluded for life. He's one of them that's never going to believe God. You know what I mean? He says he's religious, whatever that means. Religiously in love with heliocentrism. He doesn't love Jesus, that's for sure.
Well, I definitely won't call myself religious because I'm a Christian.
What the hell?
Religious person. Okay, but the fact is, the three-body problem is a problem because it's based on Newtonian mechanics, classical mechanics, Newtonian physics, which means gravity has to be a force. To make those solvable, because they had to go outside of Newtonian physics. They had to go outside of classical physics and use those different theories to sort of make sense of them. It doesn't mean it's solvable. It's almost solvable.
Brightly shine, crafted signs of the divine. I'm made for something true. In God's plan, my path renews. Flat earth made by Him, my journey long yet thin. Purpose found in every day, guided by His gentle sway.